Hi, welcome back.
Hi.
Hello. So we are working with logarithmic functions still. We're continuing to graph them, but this time we're talking about those transformations on them. Okay? These transformations are the same transformations we've been playing with like the entire year. So let's just jump right in and let's look at the transformations. This function right here is my original OG transformation. And this one, my OG function, my original function. And this one down here, my g of x, that's my transformation. That's the one that's undergoing a change. So as I look at the transformation, I notice that I have a value right here. And when I have a value right there, I'm going to be moving it left or right. It's a horizontal translation. The sign tells me the direction. Negative sends me to the right, and so I'm going to the right 5. And then back here outside of the function, I have a -7. That is a vertical translation, an up or down kind of thing. Because it's a minus, it's down. And so this is a -7. Pretty easy, no big deal. Let's scoot over to this one real quick. Same idea, I've got some sort of horizontal translation here next to the x. We're adding 2, makes us go to the right, to the left 2 units. Out here, outside of the parentheses, I have a -8, so I'm going down 2 units. And right here, in front of the function, I have a negative sign, which is going to be a vertical reflection. That is a reflection in the x-axis. Reflect x. Okie dokie. This one, we've got the same sort of idea. We've got a horizontal translation, some sort of left or right move. We have a vertical translation, some sort of up or down move. But now, right here in front of the x, I have a y reflect. And whenever I have a y reflect, it's going to alter the direction that sign tells us to go. Normally the sign tells us to move to the left, but with a y reflect, this is telling us to move to the right. Alrighty. That's all for the transformations. You just need to write these out in words. I'll let you take a look at some of my other videos on writing those for words. Let's go ahead and graph these things, okay? It looks like the most challenging one to graph is going to be, probably this one, because we've got a lot of negatives happening. All right, so the first thing I need to do is graph the original function. My original function is this one right here. This is my OG, my original function. I see a vertical translation. I see a horizontal translation. And I see a reflect in the x-axis. Now, that's if I were graphing it from some sort of parent, which is really hard to do with logarithms. So instead, I'm going to go back to my graphing by hand, which was our Unit 8, Day 3 and Day 4. So on the original function, going to write this stuff right here. I need to get some information on, give me just a second. Let's grab the vertical asymptote. So the vertical asymptote is sitting right here. So x equals -4. And now I'm going to find some nice values, okay? So the nice values are going to be where this stuff in here, this x minus 4, this x minus 4, I want it to equal 10 to the -1. Then I'm going to look for it to be equal to 10 to the 0. And then I'm going to look for it to be equal to 10 to the first. I'm grabbing 10 because that's the base of my logarithm. There's no base listed, so we're assuming it's a base 10. All right, so I want this to be 10 to the negative first. That's just 1 over 10. All right, so adding 4 to both sides gives me 4 and 1/10. And so when x is, let's put this in a decimal, 4.1. When x is 4.1, then my entire log thing, this thing right here, is going to turn into negative 1. Okay? So negative log, I'm going to grab this thing in here, which when x is negative 4, this piece in here becomes this value. But I set it up that way because all of this then turns into negative 1. Double negatives is a positive. And so the first point that I can graph is going to be 4.1 comma 4, because this is a y value. All right, I'm going to repeat for all of these others. I'm going to give myself a little bit of space here. So negative log of 1 plus 3. I did that because all of this turns into that exponent up there as 0. So my next point is 5, comma 3. For a slightly slower version of how to do this, please do double check that video day 3. We also do it again in day 4. I'm not doing anything super spectacular. So what I did again was I grabbed this log base 10 and I made it equal to that because that's my trade-off. So when x is 14, y is 2. All right, I have my vertical asymptote. I have my 3 points. I can now come down to my little bit of graph paper that I've provided for you on your notes, and I can start to graph this thing. I need to graph the vertical asymptote first, which was at negative 4. Here's negative 4. And then I'm going to go to 4.1. 4.1? Yes, 4.1. 4.14. That's a really odd number. That should be right next to my logarithm. Because it's supposed to be the opposite of this. My apologies. The vertical asymptote is this, but I forgot to change the sign. All right, so my vertical asymptote is actually 4. That makes it make a lot more sense. Let me color that in blue for you so that you can see the difference. Ignore the black line, look at the blue. All right, now I can graph 4.1 comma 4. And then at 4.14, it's on this side. And then at 5, it's 3. And at 14, which goes off the graph, it's 2. So I'm going to say it's about there. YOLO. Okay. So this is my original h of x function. All right, now I need to perform these transformations. So I'm going to look at g of x to figure out what my transformations are. My first transformation is going to be an x reflects. My next transformation is going to be a right movement of 2. So I'm going to reflect it across the x, and I'm going to move it 2 spaces to the right. I may have to guess on some places. This graph paper isn't very good. Okie dokie, I'm going to draw that in orange just so it looks different. An x reflect on a vertical asymptote doesn't do anything to the asymptote, so I'm just going to move it 2 spaces to the right. 1, 2. So now my asymptote is here. All right, with my asymptote there, I'm going to grab every point and I'm going to shove it over, x reflect, and then 2 units to the right. So I'm going to grab this one. It is 1, 2, 3 units from the x-axis, so I'm going to go 3 units in the other direction on the x-axis. 1, 2, 3. And then I'm going to shove it over 2 spaces. 1, 2. I've done that point. All right, this point, which is at 4.1, comma 4, it is 4 spaces from the x-axis. So I'm going to go 4 spaces out. Notice I'm really close to the asymptote. And then I'm going to move 2 spaces over. 1, 2, and I'm still close to the asymptote. Okay, I've moved this one. Now this guy. He's 2 units from the x-axis. I'm going to take a moment just to kind of extend my x-axis a little bit. So he's about 2 units from the x-axis, which is about here. And then I need to move 2 more units that way. I've got to guess because I don't have grid paper there. So I'm just kind of guessing that's where he should go. And it looks like I missed one of my dots. Oops. But there he is, g of x. Let's go ahead and grab this one, just so that you can see it one more time. All right, I'm going to look at my original, my OG function, and I'm going to find where I need to graph that. So that's the first one I'm going to do. I'm going to do that information right here. All right, my vertical asymptote for there is going to be x equals -3. Don't forget to change the sign like I did on the first one. All right, and then I'm going to find values of x when I get 10 to the -1st, 10 to the 0, and 10 to the 1. And again, I'm going to make this piece equal each of these nice values, each of these magic values. So that equals 1/10, that equals 1, that equals 10. And I'm going to find out where the thing I'm taking the logarithm of equals each of these values. All right, so here subtract 3 from both sides. That should be -2.9. This one subtract 3 from both sides, this is -2. And this one subtract 3 from both sides, I get 7. So when x is 7, I'm going to zoom in just a little bit more. Okay, on this first one, when x is -2.9, the entire logarithm gets to be replaced. So all of this, let me grab a different color. So all of this I can replace with this exponent when I use these values of x. Okay? So for the first one, when x is -2.9, I can replace all of this log of x plus 3. I can replace all of this with a -1. That's my shortcut. Okay. And so when x is -2.9, y is 1. Over here, when x is -2, the Log of x plus 3 becomes 0, and then I have the plus 2. Again, it's the same ideas right here. Let me go ahead and write in that log so that you can see what happened to it. This is getting replaced with this. So y equals 2 in this case. So when x is -2, y is +2. All right, the very last point that is easy to find to graph these by hand. When x is 7, this entire thing becomes this exponent. So I get to do that replacement. And so when x is 7, y is 3. Right, I'm going to zoom out and I'm going to graph all of these different items. I'm going to graph my vertical asymptote, and I'm going to graph my 3 very nice points. I'm going to go ahead and graph this guy, the original, in orange today. All right, so my vertical asymptote is at -3. And I have a point at -2.9, comma 1. I have a point at -2, +2. And I have a point at 7, comma 3. All right, and I didn't miss the point this time. There it is, and this is my f of x. Fabulous. Now to draw the transformation. I'm going to draw that transformation in pink today. There it is. My transformation says that the first thing I need to do is I'm going to shove this thing 5 units to the right. And then I'm going to shove my points 2 units up. So I'm going to grab everything, including the vertical asymptote. I'm going to shove it 5 to the right and 2 up. So coming back to my graph, looking at my asymptote, 5 to the right. 1, 2, 3, 4, 5. My new asymptote is right here. And then I'm going to grab each point and I'm going to move it 5 to the right, 2 up. You might be asking why I didn't move the vertical asymptote up, because it's a vertical line. Vertical movements, vertical translations, vertical reflex on a vertical line, it doesn't do anything. All right, so grabbing this point, I'm going to shove it 5 units this way. So 1, 2, 3, 4, 5, and then 2 up. 1, 2. I did this one. Okay, this point. 1, 2, 3, 4, 5. 1, 2. I did this point. And now this one. 1, 2, 3, 4, 5. 1, 2. And so now my transformed graph looks something like that. Okay, so hopefully we feel a little more comfortable with graphing those transformations. All right, let's answer the 2 challenge questions at the bottom. The 2 challenge questions at the bottom want to know which functions were reflected in any way. What you're looking for is you're looking for a negative in this position and a negative in this position. Those are the ones that are going to control some sort of reflection. The next challenge question says, which of the functions have a domain of all real numbers? What you need to remember is that domain is asking about all the possible x values that this function can take. All right, give me your answers to those 2 challenge questions in the comments below, and I'll see you later.